Hi, everyone. I am really happy to see so many names here in the list because I can't see any faces. But this is such a cool event, pun very much intended, and I'm happy to be part of it. There is a lot of great sessions going on today, so I'm very thankful to see that you are dedicating your time to listen to me. For many of you, this session will seem basic and maybe even pointless in the beginning, but bear with me, there is a purpose to this. My hope is that you'll leave this session with a new outlook on an established truth. Just because we've always done something in a specific way doesn't mean we should do it in that way tomorrow. So, I am going to tell you how my first experience with Azure Data Factory came to be. And yes, this is a day about Synapse, but you and I both know they are like siblings. I work for a consultancy company, and we do many different kinds of projects. And a couple of years ago, in my first ever project I was placed in, included ADF as one of the tools. At that time, my only knowledge was how to create activities and the main purpose of the tool. The senior of the project team developed all of the pipelines, activities, and parameters, and then she had to move on to the next project. So there I was, all by myself, even more so because of the ongoing pandemic, so everyone worked from home. I found myself in a technical environment where I was meant to continue the development and to manage the solution. I guess you know where I'm going with this. So what do you say when I also tell you there was not a single line of documentation? It didn't take long until I ran into big trouble. So I had no choice but to learn every bit and piece of the solution. And to do that, when you are totally new in the industry, in the tool itself, in an environment you haven't built and you are supposed to write the documentation about, that's a big mountain to climb. So it was time to put my big girl pants on and get to it. So who am I? My name is Linda Torrång, and I'm working from Stockholm, Sweden for a company called Atollo, where I'm a data warehouse and business intelligence developer. And my background is probably not what you would call a typical BI background, as my experiences come from retail and journalism. But I have what is most important in this industry, a strong desire to learn new stuff. So in my early 30s, I went back to school, and from day one studying business intelligence, I loved it. And I tried to mix my business knowledge and curiosity with technical skills to build great solutions for our customers. This is the agenda for the session. We are going to establish what I refer to as an implementation pattern for the real world, how to adapt to it and build for it. So for those of you that don't know what Azure Synapse is or what it can do, and I know that description doesn't apply to the most of you, but as I said earlier, there is a point to this. Therefore, we are now going to get a really fast, really high-level introduction to the tool itself. This picture is taken straight from the Microsoft Docs website and does a really good job of explaining the bits and pieces of Azure Data Factory. Again, it's practically the same as Synapse. Trouble is, there is a lot to take in. So let's break it down a bit. Simply put, Azure Synapse Analytics is a cloud-based tool that can transport and transform your data. That's it. It can do so in a more or less complicated way, but at the end of the day, this is what the tool does. For starters, we are going to look at Synapse as a data movement tool. You grab your data from somewhere. This is called the source, and you drop it off somewhere else. And this is called the sink. In order to connect to the source, there are a few things that need to be set up. For starters, we need a linked service, and this is essentially a connection from Synapse to your data source. The data source can be anything Synapse has a connector to, and that's just about anything you can think of. In this example, we can set up a linked service to a blob storage to use as a source. And by setting up another linked service to an Azure SQL Server, we can sync the data from the source into that. This linked service works pretty much like a connection string to whatever external data store you want to use. If you fetch data from one place like a blob storage and are going to transport it somewhere else, you need a linked service for each connection. Unfortunately, it isn't quite that simple. What if we have multiple blob stores or several databases on the same SQL Server host? Yeah, we need one or more level of control. So enter the dataset. This is an exact pointer within your linked service, like one of the two databases in the same SQL Server host, for instance. Now we are getting somewhere, but we also need to decide on how we want to use Synapse. There are three options for the so-called integration runtime, i.e. how the compute resources used for data movement and transformation should behave. The first one is called the self-hosted integration runtime. Don't worry, it won't be parked in your on-prem environment, but it is designed to be able to reach into your on-prem environment, and thus the choice for hybrid scenarios, where data needs to move between on-prem and the cloud. The Azure integration runtime, on the other hand, is designed for intercloud data movement and brings some things to the table that the self-hosted integration runtime does not. This is a quick overview of Synapse, so I won't go into more details than that. But finally, we have the Azure SSIS integration runtime. We kind of recognize SSIS from the old days of SQL Server integration services, and indeed, that's exactly what this is. It gives you a way of running old school SSIS packages inside of Synapse. And while it works, there are some potential hazards with it. But more importantly, there are potential cost implications. All right, all done. Let's turn this on. But wait a minute. So far, we've only set up the infrastructure, connected the cables and turned on the power. We have yet to define any work. Time to take a look at pipelines. So, pipelines are like packages that contain specific tasks to be performed by Synapse. As with most everything else in Synapse, they seem simple enough, but turn out to be able to get pretty darn complex, pretty darn fast. A solution is built with pipelines, and a solution can contain one or more pipelines, and every one of them may or may not have sub-pipelines. You can think of a pipeline much like a train, where you place your cars to be moved in the right order. The engine is the main pipeline, if you have one to rule them all. After it comes cars of sub-pipelines, and in every cars there is cattle, aka our activities, and the fleece on the cattle is our parameters. The sub-pipelines, or train cars if you may, can be executed sequentially or in parallel. The activities can be anything like a lookup, copy data, a store procedure. You can set or append a variable or a for each. There is a lot you can do. And as I told you earlier in my example, we are mainly looking at transporting data, not so much transforming it. So here we have mainly used lookups to know which source we are dealing with and to log some information onto a copy data activity to establish the source and destination, and then a store procedure to insert new and update current data. And to finalize the chain, we have two different store procedures, both executing the same procedure, but depending on if the previous step was a success or failure, it produces information about how many rows that's being transported and other information. And just as a side note, this is just a tiny part of the whole pattern. This is one of the sub-pipelines. And then you place triggers on the pipelines if you want them to run automatically. There are currently 3 ways of triggering a pipeline, either on a schedule, like a wall clock, or a tumbling window trigger that operates on a periodic interval, or through an event-based trigger that responds to some kind of event occurring. And there you have it. That's the main components that need to be established to get a Synapse solution up and running. So, my topic, Synapse Pipelines implementation patterns for the real world. Let's face it, reality is harsh, cold, and often rather frustrating. The point of an implementation pattern is to make sure that things are done in a consistent, well-documented, and efficient manner. Keywords are reuse, consistency, and adaptability. That was the issue in my case. There were just words, as I didn't know what had gone into creating the pattern in the first place. There are several ways to create a solution. Some good, some not quite as good, but each and every one of them has its own purpose. And that's the one things I concluded at this point. You have to figure out the problem your pattern is trying to solve. Then build towards the solution, not only following the pattern handed to you. And the more I looked at this, the more I realized that an implementation pattern is but one side of the coin. The other side of the coin is the why. Why are we doing this? What are we trying to solve? Just like IT in general never has a purpose of its own, but is always a support structure for the business, the architecture pattern is but a tool to be used to further a goal. The pattern is not the goal itself. And if the underlying philosophy of the pattern is shrouded in darkness due to either poor documentation or, as in my case, a lack of experience with the tool, it is easy to fall back to just trying to implement the pattern and to hell with the consequences. The idea is sound. The company uses their brightest minds to come up with a reusable architecture pattern, canned and ready to implement. It really doesn't matter if we're talking about Synapse patterns or just a pattern to build a data warehouse. The idea is literally a shake and bake solution to a problem. A standardized solution to make sure you deliver a correct and clean result is just common business knowledge. If only every problem were the same. Unfortunately, this is rarely the case. Reality is messy. 2 customer projects are rarely going to behave the same, even if they have similar problems. But from enough altitude, they might seem the same. And here comes the fundamental issue with a fixed implementation pattern. It is somewhat inflexible. Your pattern is only as good as the person implementing it, because it really is impractical to bring a chainsaw to a dinner table when you only need a table knife. A great solution can most probably do the work for most situations, but it doesn't have to. A small project for a customer who doesn't need all the stuff that a big project needs will probably not be happy to pay for all of that extra. A more intricate solution pattern will not only take more time to develop, it will also cost more, as well as have a multitude of moving parts that all need care and comfort. So you need to be able to scale your solution. Since scale only is a euphemism for flexibility at this point, we are back to flexibility in the pattern. And that's what an implementation pattern for the real world really is. no matter the tool or problem at hand. And I'm going to walk you through some key points that you can use to decide which level of complexity you need when developing a pattern in Synapse. First, let's go back to where I was a couple of years ago when this session started taking form in my head. I didn't know much about anything in ADF and less so in Synapse. But I do know business. And I realized quite fast that the way I went about learning everything from scratch wasn't the most effective one. I didn't really know where to start, and I sure as heck didn't know where I was going. I just doubled down and moved the only way I knew, forward. And what was that way forward? Well, yeah, smash the solution into pieces and try to figure out what the pieces there were, how they really fit together, and most importantly, why they were there in the first place. So, armed with the Microsoft documentation and an unhealthy dose of let's poke at stuff and see what bleeds, I went back to the pattern and tried to make sense of it. It went about as well as you could expect. But in time, I learned how the pipelines worked and what the activities did. Things were starting to make sense, but the number of pipelines and activities I was going to need was becoming an issue. With no background in integration tools like SSIS, I didn't quite grasp the corner I was painting myself into with this way of creating a solution. But then I stumbled upon parameters, and it dawned on me that this might be the solution to the desired flexibility. This seemed to be the key to automating stuff and not having to endlessly repeat all the pipelines and activities for different purposes. This way, I could build the mother of all pipelines, the one unicorn that could do all of the things. It doesn't get more flexible than that. Here's what makes parameters so great. In every activity, you can set parameters as few or as many as you like. They can also be used globally at the pipeline level. Setting parameters up here means that they'll affect everything in the pipeline, meaning that the need to endlessly duplicate settings over and over again just flew out the window. A parameter can be explained as a pointer to something that you could twist and turn according to your wishes. For example, you could set a parameter for a dataset and then use the same activity for different sources simply by changing the parameter. This has enormous potential, as almost all identical activities and pipelines we've built so far can be reduced to way fewer activities, maybe even one. In fact, this is where most projects where a member who's just discovered parameters is heading, and that might not necessarily be such a great thing. When you realize the power of parameters and their effectiveness, you get carried away fast. And that's where you could get lost. Because then you might start building this solution with parameters to control everything. And while we're at it, produce a lot of extra data, such as logging or monitoring information. With this flexibility, unfortunately, comes complexity. And while this might be an excellent idea in a big project, it might actually turn back and hurt you if the scope of the project is small. It is vital to step back and try to determine what you really need. If a super complex solution with a gazillion parameters is the right way to do it. Just because you can doesn't mean you should. This takes quite a bit of self-control. I'm the first one to admit that. So, given that we can create anything from an infinitely duplicated contraption with an abundance of almost identical pipelines to a highly parameterized marvel, how do we figure out what a reasonable level is? What questions do I need to ask myself and the recipient? Like, do we have a budget to stick to? Are we facing a hard deadline? Should it be a super solid solution from the get-go, or could it grow over time to become fully developed? All of us wants a project that can deliver on all three corners at once, but that's not doable. So pick at most two of them, maybe even just one. And to do this, you have to get to the essence of the receiver's needs. We moved beyond the code, we moved beyond the technology, we moved beyond the pattern. Here we are starting to glimpse how we can evolve a pattern into a solution. We need to figure out what requirements are must-haves and what requirements are nice-to-haves. Most of the time, I find that a lot of requirements start out in the must-have category, only to be moved to the nice-to-have as time or cost or other limitations makes themselves known. Spending time in this phase will always save time in the implementation phase. A penny of prevention is worth a pound of cure, as the saying goes. So take the time and really conclude what is the absolute must-haves and what is just nice-to-haves. Maybe you need to keep to a certain fixed budget, and that trumps the timeline, or the other way around. Establishing requirements is an art in itself, and something that could easily make the essence of a session or two on its own, or several. So, okay, let's recap and see what we have in place so far. We have the pattern, we have some knowledge, and we have figured out the basic requirements. We are really getting there, but we're not quite there yet. We now have the required information to answer the question of how complex a solution we want to create. Remember the limiting factor from previously? We might be constrained by budget, time, or something else. How does this apply? Well, the first question when the time comes to actually start building a project in Azure Synapse is whether to build a static solution or a dynamic one. We've touched on how parameters enable you to create a more flexible but potentially more complex solution that minimizes duplication. Now, a static solution is by no means automatically a bad choice. In fact, you might start with a static solution and develop it over time to a more general dynamic one as the requirements get firmed up. Then again, if the project is firm from the get-go, it might save time to implement a thoroughly parameterized project from the start. As we all love to say, it all depends. So what is this static pipeline thing then? Well, let me show you. A static pipeline might well not need any parameters at all. It might just consist of a hard-coded source and a sync definition. It could literally be a copy data activity for a specific table being sourced from somewhere and sunk into something else. Dead simple. And it might just fit the bill perfectly. The problem is that this won't scale very well when you need to make several similar pipelines. In fact, it becomes not only tedious to work with, anyone who has ever worked in the Azure Data Factory Studio knows how much fun it can be to copy and paste pipelines, but also susceptible to errors. I mean, consider what would happen if you need to change the source definitions to point to another blob storage. It would need to be done in every pipeline. It's easy to see how a mistake could be made that could derail the entire day. And then you might instead need to go towards a more dynamic solution. A dynamic solution could consist of a few parameters that might just be a dynamic source and destination, or it could be very complex with many parameters for several different purposes. A good thing to remember is that the dynamic solution will take longer time to start getting things in place. and it will be more complex to troubleshoot. Having said that, you will probably most always gain back the time lost when implementing the more complex dynamic solution, when the number of pipelines start to increase. The upfront cost will be larger, but the potential savings going forward will be worth it. A hard-coded static solution can therefore be useful for a small project when you need to get things up and running fast. Here are some questions to help you to figure out which direction to go. Is it a one-off thing? Are the transports only going to happen one time? Not very common, but it happens. Or will this be a continuous solution that needs to be maintained? Is your solution going to grow? Can you see a future when more things will be implemented in the solution? Should we build for a scalable solution? Is the number of tables or schemas involved low? If it is just one table or schema, then you don't need parameters, because then you could point to a certain schema or even table. You don't have the need to be flexible with that. Maybe you just need a wildcard. Is the source and destination static or likely to change? If you always fetches from the same source and send to a destination, that can be different from the source, but the same destination for the things you transport, then you don't need parameters to be flexible with your dataset. Do you need to keep track of pipeline execution? Well, if you want to log how many rows you're transporting, or just if the executions was a success or not, then you might need to set up your own solution for it instead of relying on the alternatives for monitoring in Azure. Those are some of the questions that you can start off with to establish a static or dynamic pipeline. And if you are going down the dynamic route, the question then becomes, how dynamic? Just because you can doesn't mean you should. In my mind, we should have a base pipeline, one pipeline to rule them all, to do the orchestration. To start small and build your way up to a more complex solution. That way you can make sure you only have what you actually need to build the solution you're aiming for, instead of using everything in the kitchen sink from the beginning. Something like this, basic, easy to understand, and simple to develop further. We can add on things from that simple starting point, for example, activities which can produce some logging information. Or why not a dynamic source parameter? Or we could make even more activities to log as much as we want. The sky is literally the limit. We are in the cloud, remember? So, going back to my train wreck of an introduction to Data Factory, I faced a huge pile of Legos. I probably wouldn't have learned as much as I did if I had documentation to read up on, but with that said, it wasn't a very pleasant way to learn, at all. I had to break down every bit and piece of the solution to understand what it did, where it came from, how it worked, and why it did, or didn't. Then I had to try to piece the whole thing back together again. But now I had much more to work with. I even had a fairly decent instruction manual explaining how the pieces fit together. And how do you build anything in Lego? Well, you start from the beginning, putting one piece on top of another, and time to figure out if what I have learned so far actually held up in reality. The issue with the instruction manual at this point was that it still was somewhat inflexible. I had the pattern, I had the skills, and I had the requirements from the customer, but something still felt like it was missing. I mean, I would be quite capable of actually implementing the project with the information I had collected, but I really hadn't done anything differently from when I was thrown into the deep end of this project. I was lacking the final piece of the puzzle to turn a pattern into a proper real world solution. I was lacking instructions for building variants. I have already mentioned, and in my view, the documentation for a solution pattern is just as important as the solution itself, no matter what you build. The thing is, you don't really have to write down every little detail. One of the best things with working in Synapse or ADF or anything in Azure really is that everything literally is infrastructure as a code. Everything inside of your tool can be expressed as JSON code, which means that the infrastructure setup is just about self-documenting. What is not documented, however, is why the solution looks the way it does. And that is the difference between starting from zero, trying to figure everything out by trial and error, or hitting the ground running. I had faced the former, and I didn't want to put the next Linda to come along through the same ordeal as I went through. Not only for her, but this documentation will obviously also come in handy for the receiver of the solution, when they try to make sense of what they have been handed, as well as any other developer being asked to expand on the solution in the future. The most important thing that's more important than any kind of high-level or granular documentation is to explain the why. Just consider being handed a documentation that clearly explains the choices of one design philosophy over the other. You might not agree with the choices made, but you don't have to tear your head out to trying to understand how someone could have come up with a solution like this. And remember the decision tree from before. Not only is it useful for figuring out which way to go, it is also perfect for putting into the documentation. Visible and easy for everyone to understand why you made the decisions that you did. And while we're at it, why don't you throw in some cost estimates to show what the difference between the solutions would have been at the bottom line? Heck, you could even list the competence levels of the ones involved. What can we make with the resources at hand? It could even be great for you to circle back to a year later and evaluate. That was the purpose and conditions at that time. Have they changed? Just see to it that you explain the why of the solution. Then, of course, someone like me would love all the parameters explained to and what they do and how, but that is not the primary need. If within your organization you have the kind of solution patterns that we do, then it might also be a good idea to have a documentation explaining your base pipeline and the additions and subtractions that could be done with it. View it as another step in establishing a great pattern. New colleagues get to know the bits and pieces really quick and easily and know how to adapt to the pattern to the challenges faced. The thing is, this is not only for junior developers trying to learn how to implement the pattern, but also for more senior developers looking to add to their own box of tricks. As with everything, the longer we work on something, the more ingrained and taken for granted it becomes. Until the day you either come back from vacation or simply have been away from the project for a while. Some people say documentation is uncool. Well, I think it's pretty darn cool to be able to pick up where you left off without having to spend a long time figuring out what you heck you did last year. That is great business all the way. As we've seen, it is a great idea to sell a ready-to-implement package, but the pattern itself is not a complete solution. It is part of the solution, but not the solution in itself. Combining a pattern with skills will give you the ability to write the code. Adding the customer requirements to that will tell you what might need to be changed in the pattern to better adapt to it in the real world. Adding a good documentation explaining why the pattern looked the way it does will finally give you the last piece of the puzzle to turn that pattern into a proper solution, an implementation pattern for the real world. Take that box of Lego and twist and turn it, all the pieces you're so familiar with, and build what you need, not what you're used to. And if you're lucky enough to have a manual for the different levels of complexity, then you're halfway there. So, to recap, a solution pattern is great to have, but you need to be flexible with its content. Build for the need, not what you're familiar with, not the things you find cool. When you can work beyond that, that's when you build for the real world. When you have business and tech intertwined, is what I call implementation efficiency. And this is why I dragged you through all of the components and building options. This could literally be any kind of tool or solution to build. Make it more business. Don't just focus on the technicalities. That's what I want to bring to this table. Anyone can build this solution, but a pro can make great business out of it. Don't bring that chainsaw to a dinner table. Bring a machete. Bring a pocket knife. Or best of all, bring a lightsaber. Just bring what you actually need. And what I learned is that you should never make it harder than it has to be. A million parameters won't always make a better solution. Use the possibilities wisely and show off your skills by producing a solution that is actually adapted for that particular project. Make your implementation patterns really work out there. I hope you've gained some insights from this and that we all can agree not to build overcomplicated things just for the fun of it. And as the old rule says, less is more. My name is Linda, and I hope you learned something. Thank you so much for listening.